Here we have honors algebra 2 math problem. That is, we have to find some of this infinite series. So because here the ending value of n is infinity, so it's an infinite series. So we have to evaluate this. Okay, to evaluate this infinite series, first we have to identify the series. I mean, what type of series is this? So for that, we have to plug in the values for n. So the starting value for n is 1. So when I plug in n is equal to 1 into into the nth term of this series, so what will happen? So when I plug in n is equal to 1, this part will become 1 minus 1, 0. So 6 times 1 over 3 to the power 0. Anything to the power 0 will be 1. So 6 times 1, I get 6. So when I plug in n is equal to 1 into the nth term of the given series, I just get 6. That is the first term of the series is 6. Okay, now to get the second term, I have to plug in n is equal to 2 into the nth term of this series. So when I do so, 6 to the power of 6 times 1 over 3 to the power. When I plug in n is equal to 2, 2 minus 1 is just 1. When the exponent is 1, you don't have to mention. Since we have summation, we have to add all the terms. I mean, we have to add the terms when I plug in n is equal to 1, 2, 3. So I'll be getting the terms of the series. I have to add them all because it's a series that is we have summation. Summation means we have to add the terms which I get when I plug in n is equal to 1, 2, 3, 4 into the nth term. Okay, now I have to plug in n is equal to 3. When I plug in n is equal to 3 here, so 3 negative 1 which will become 2. So 6 times 1/3 to the power to the second power. Okay, when I plug in n is equal to 4, 4 negative 1 will become 3. So 6 times 1/3 to the power 3. So in this way, it keeps going infinitely because it's an infinite series. So the ending value of n is infinity. It keeps going infinitely. Okay, now it's clear. So when I look at the series carefully, the first term is 6. And to generate the second term, we have to multiply the first term by 1/3. Okay, from second term to third term, if I want to generate the third term from the second term, again I have to multiply by 1/3. So to generate the fourth term from the third term, again I have to multiply by 1/3. So clearly, it's a geometric series because each term is multiplied by a constant value to generate the next term. So it's a geometric series with the first term, that is a1 equals to 6, and or the common ratio. Common ratio is nothing but the number by which we multiply each term to generate the next term, that is 1/3. Okay, an infinite, so it's a geometric series, and particularly this is infinite geometric series. So whenever I want to evaluate an infinite geometric series, it can be evaluated only if it is a convergent series. How can I know whether a geometric series is convergent or divergent? If it is divergent, we cannot evaluate it. If it is convergent, we'll be able to evaluate the value of the given series. Okay, how can I know whether an infinite geometric series is convergent or divergent? So look at the value of r, it's 1/3. So the value of r has to be between -1 and +1. So only for any infinite geometric series, if the value of r is between -1 and +1, so it will be convergent and we will be able to evaluate the geometric series. In case, what if the value of r is out of this interval? That is, the value of r is greater than 1 or less than -1. So the given infinite geometric series will be divergent and we will not be able to evaluate that one. So here in our problem, we just got 1 over 3. 1 over 3 is nothing but 0.333. It will keep going. So we get this value between -1 and +1. So the given geometric series is convergent series because the value of the common ratio is between -1 and +1. Since the given infinite geometric series is convergent, we'll be able to evaluate the sum of this series. And whenever there is a convergent infinite geometric series, so the formula to find the formula to find the sum of the terms in the given infinite geometric series is going to be a1 over 1 negative r. So a1 is the first term of the series, which is in this case 6 over 1 negative. The value of r is 1/3. Okay, now to simplify this one, I multiply this integer by the denominator of the fraction 3. Once I'm done with this multiplication, I have to take this 3 as a common denominator. That is 3 negative 1 over 3. Okay, here 6 over, so it is simplified to 2 over 3. So I write the numerator as it is and I change the division as multiplication and I take reciprocal of this 2 over 3 which will become 3 over 2. So 2 goes into 2. 1 times 2 goes into 6 thrice. So 3 times 3 will become 9. Okay, now I've evaluated the given infinite geometric series. So its value is 9.